In this tutorial, we are going to see the notion of finite capacity. We have created a simple queuing system using JSIM graph, where jobs arrive into this system in class 1 according to exponential inter-arrival times. This exponential distribution has a rate of 2 jobs per unit of time. So, for example, in 1 second you may have an arrival on average of 2 jobs. If we look at this queue, this is a simple first-come, first-served queue, and we have that the service is again exponential with a rate of 1. So in this case, jobs arrive at a rate of 2, but they're processed just at a rate of 1. So the queue will not be able to match the frequency of the arrivals, and the queue will grow indefinitely. We try to simulate a system like this with JMT. If we look, for example, at the response time, we're going to see that the simulation will never converge to a fixed value, and the response time will continue to grow because the new jobs that arrive will queue behind the ones that are already there, and the queue will be able to process a few of them, but not all of them. We call this queue a saturated queue. And as you see, there is no convergence for this measure because JMT could not find a convincing value for the estimates. We therefore can introduce a modification of this queue to cope with the speed of the arrival process. If we double click on the queue, you see here in the queue section under capacity, you can specify the maximum number of jobs that can wait in the queue buffer. So we specify this to be a finite value, and we say that at most 10 jobs can wait in this queue. And as you see, once we select a finite capacity, we need also to specify a drop rule, which clarifies how JMT should cope with jobs that arrive to this queue once the buffer is full. So let's give OK. We chose here a drop rule, which means that the jobs that arrive when the queue is full will be discarded. And now we play again our simulation. And what we see now is that very quickly JMT is able to provide an answer because all the jobs in excess of these 10 has been discarded, and so the queue does not saturate. We see in this case that the response time is 9 units of time on average.